we're broadcast. Okay, so I'm going to go ahead and put, I'm going to go ahead and bring up the actual assignment, and we'll just go over. All right, good. Share screen. Okay, and let's go to work. All right, so here we are. One of the two conditions must be satisfied in order for the distribution of the sample means to be normally distributed. What are these two conditions?
The parent population is normally distributed, and the central limit theorem guarantees the distribution of bar X as normal if the sample size is large enough.
Yeah. So basically, normal distribution, in what I found in a nutshell, normal distribution, which has been classified, or if the population is large enough based off the central limit theorem. If you could, that's all I have to remember, because that definition, I was like, that's wrong. All right.
It is.
All right, what is the z-score formula for a sample mean that is normally distributed? So that was based off of the z equals the sample
value minus the mean.
Yeah, sample size. Yeah, minus the mean over the standard deviation over the size, right?
Okay, I don't know. Like I put z equals value minus mean divided by standard deviation.
Yep.
Divided by bar X minus mean. Divided by standard deviation divided by square root of sample size.
That is correct.
Okay, that's what I have. And I don't even know how to apply that to, you know, maybe that's why, because I was looking at a different I was looking at a different equation, so maybe that's why I'm like, huh?
Yeah.
Okay, anyway, go ahead. I'm sorry.
Not a problem. So going to 3A, what is the probability of randomly selecting an individual observation between 5 and 15? When I got to this, I'm like, I didn't understand that, but I like what he did. He actually drew, so, you know, if I could do that, he drew like the bell curve. And then he put the mean is 10, and then he said the standard deviation is 5, and then 5 and 15. Right. So that means it's in that one standard deviation. So it's a 60, 95, 90.7 rule. So it's 68%. So that made sense. So what is the?
Yeah, once I looked at it, I was like, oh, that does make sense.
Yeah.
Sometimes I have to work backwards. I think I might be dyslexic.
No, reverse engineering, we'll call it. There we go.
Okay.
What is the 40th percentile of the population? So I actually had to I actually made sure, where am I? I actually did the applet. So I had to change it to right there. And that's how I got that, the actual percentile. I mean, the percentile is there. What is the population? And so you had to work backwards. So you already know, what the score is and is. So the 40 percentile, so everything, so it's a negative. So it's going to be a negative because it's 40 percentiles right here. And then you have to take the X minus 10, which is over.
You know, I have a question.
What's that?
Whenever I use the normal probability applet and I put in the area 0.0 or whatever, it gives me like some error message.
I had the same problem. You know what I did? I started moving this, and somehow I just like broke the mold, and then after that I just did.
Okay.
That was I had the same problem.
All right.
And so when you do that, you go. So you have to do it reverse backwards, since you already know. You know the z-score, so you don't know the x, which is the variable mean, right? Value. Sorry, the value. So you're trying to get x, so you go 5, reverse it to so 5 times 0.253 times 10 is the equation in this, and so that would come out to be 8.73333. Is the.
Show me your equation, please.
Okay, so here, let me just, where am I? Oh yeah, I gotta go back here. All right, so what I would do is, okay, so the formula is, so let me just get you there, right, 0.25, oops, 253 equals.
Because that's the z-score.
Yeah, x minus 10, which is the u, whatever the divided by the standard deviation of 5.
Okay.
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 So
we did that a couple of assignments ago.
Yes.
Okay.
2 assignments ago.
Yes. All right.
We're talking about the population. We're doing the population one, not the random sample.
Yes. And we're getting rid of.
Okay.
We're solving for x basically.
Yeah, and so you just say, and then the equation becomes x equals 5. Oh, I'm sorry, negative. Sorry, I gotta make sure that's negative. And that will equal, so x equals is 8.7. Okay. Does that make sense?
Yes, thank you.
So now this, is the formula for this one is z equals 18.5 minus 10 divided by 5. So that would come out to 8.5. So hold on.
Yeah, 1.7.
Yep.
Is that what it was?
Yeah, 8. Yep.
It was 1.7.
Yep. Equals. There you go.
Okay.
Then again, this one is z equals 12 minus 10 divided by 5 equals 0.4. So we go to 0.4 on the applet because it's asking for is greater than 12. So hold on, let's go there. What did I say? 0.4?
Mm-hmm.
There it is. 0.3446. Okay. And since now number E is what is the probability that an individual is less than 8 or greater than 12? So it's the same thing. So you just take that because greater than 12, we already figured it out, 0.46, yeah. And then less than 8, which would be if you were to just spice same mathematics, it would equate to the same thing. So right. There you got 0.682, and that's your answer.
Okay.
Yeah. I don't know if you have it, but I just finally got this put on like one of my favorites because I got a feeling I'm going to be using this quite a bit in my computer. So.
Yeah. It's just that I've been struggling to use it. I didn't know I needed to jack around with it like that. No,
and it's like, what does that all mean? And I totally, yeah. It took me a while to figure it out myself, and it was like, oh, this is actually a pretty powerful tool once you figure it out. But if not, it's not.
Well,
it's
like whenever you're using it in the lesson, I'm like, wow, this is so neat. And then when I go to use my applet, it doesn't work, and I'm like, wait, what?
Tell me you want a money refund. Yeah, just saying mine's broken.
Seriously.
All right, number 4, sample size of 4 from a normally distributed. What is the shape of the distribution? Normal, because just of this, yeah. So it's normal. And then number 5, the sample size are from normally distributed. Well, it's normal already. And what is the shape of distribution X? Well, since the size is now large, it is because of the central limit theorem. It is now going to be normal too. So here's my question before we go any further, and I don't know how to ask this. What is a large number then?
I don't know, but in the lesson it says that anything over like 30, I think.
Is that what it is? Is that what it said?
Think so.
All right. Well, that gives me the thing to think about. So this one, if we hadn't worked on it, so I was just like, Z equals, if you don't remember, it's 40 minus 45 because the sample is right here is taken. The sample size is 4.
Yeah.
Which is right here's the number. X is the 40, so 40 minus 45, which is up here with the mean, divided by the actual standard deviation, which is standard deviation is 10, divided by the square root of, sorry, make sure I do this first, since I can't, I don't have a square root.
I don't either. I don't know which button that is, so.
Square root of 4, because that's the size right there, sample size. And then that will come out.
Okay, yeah.
So, and then, so that one would be, so you got that's -5, taken the square root of 4 is 2, 5 and 5, so you have a -1. All right. Okay. So
where did you get a -5 at?
The -5. Okay, so square root
from the 45.
Yeah, -5, and then 10 over 2 is 5. So you now go to the applet again.
Yeah.
You go -1, and then sorry.
Man, you make this look so easy.
Well, I'm a good regurgitator. I just watched the thing right, took the notes meticulously, and able to regurgitate. But I also, it's starting to make sense, is I can explain it if you tell me exactly the words it is. So here it is. So you want to make sure it's less than 40. So we got to make sure. So less than 40 means anything from, this is the number that it came out to. So this would be less than 40. So that's -1, and here's your probability, which is 15.87 or 16% is what it said in the thing. So moving on, let's same.
Write that down real fast.
So Z.
You go ahead. I'm listening.
Okay, Z equals 35 minus 45 divided by. Sorry, I just really have to. If I don't do this fast, I'm like I lose. I have to write it down fast, otherwise I lose it. So that again, -35 minus 45 is -10, and this was, we already knew that was it was a 2, so that would make it so 10 minus, I'm sorry, this is 5, so 10 minus 5 is -5, so this is going to be equal to -2. And since 55 is the opposite of, because 45 is in the middle, 55, we can just assume that it's going to be a +2, just because the same distance from 55 to 45 is the same as -35, but one is a negative and one is a positive. So the 55 would be +2. So we put that in there. So, and it says between, and there it is.
Yeah.
Okay. So 95.45%. Is this starting to make sense?
Yeah.
So Z equals, now we have, remember, things have changed, is that the sample size is now 25 instead of 4. So we got to make sure that we apply that. So 41 minus the 45, divide that by 10, divide that by the square root of 25 equals, so that's -4. So it'd be -4 over, this is going to be 5, 2. So it will be, so 4 over 2 is going to be -2. Does that make sense?
Why do you have -2? What did you do?
41 minus 45 automatically puts it in, it's a -4. And then this is, so that's 5. 10 divided by 5 is 2. So you have -4 over 2. Sorry, I skipped a step. So so that equals -2. And then in 49 is the same distance from 41 is to 45. So it's 5. So it's going to be a +2.
Okay.
So we go back, and then so we just do number 9, and then we just again apply the same. It would be the same principle that was in number 8 because it's both 2 and 2. So it would be the same 95 percentile. I mean, sorry. No, I'm sorry. Am I on the wrong one? Yeah, I'm sorry. Let's go. Oh, no, 9 is right here. So what is greater than 50? So again, we'll do z equals 50 minus 45, divide that by 10 divided by the square root of
25.
Thank you. And so now we got, so that's 5 divided by 2 equals 2.5. So then let's go back to the applet right there. Put it in positive because it was, and they want to know what is, it talks about what is greater than. So you got to go this one. There it is. Does that make sense?
It does. It's so easy now. I'm like, this is ridiculous. I can't believe I missed that.
Well, like I said, I need someone to show me. I'm a visual learner, and that's why I really like this class. Is that tutorial is like, wow, that was really, really simple. So, and they weren't giving me the solid answers. I mean, this does, but now, whatever.
Yeah.
All right. Let's go into this one. All right. So the sample size of n are taken from the right skewed 20 to blah, blah, blah. It's the right skewed. So what is its distribution? It's automatically going to say right because it's the sample size is only 4.
Yeah.
So and then 11, since the sample size is now 40, automatically now goes into normal distribution.
Because it's large, right?
Right, because of the central limit theorem. And is there a theorem that justifies your answer from 11? Well, yes, central limit theorem.
Right.
All right. So, okay. And can you compute? All right. So can you compute this on a normal probability applet? Well, since the size is already 4 and it is right skewed, no. Because the applet is distributed by a normal distribution, it doesn't figure on a right skewed.
Gotcha.
Okay. All right. So this one, same formula as before. So you go z equals 36 minus 40. Divide that by the 12. Oops, I'm sorry. I'm sorry. This is 36.5 minus divide that by the square root of 6. So the answer comes out to, so this would be, so 36 square root of 6 over 12 is 2. So, and then that becomes 3.5 over 2. Does that make sense? So that would come out, huh?
Yeah, I'm listening.
Okay, so that is 1 point, oops. 1.75. So again, we go to the applet, 1.75, and there's your answer.
Yeah. So easy.
Sorry. That is the answer. Because it's greater, it was a negative 1.75, not a positive. My bad. So, and then 15 is the exact same principle. It's 37.5 minus 40 over 12 to the over the square root of 36. So that comes out to 2.5 over 2, which comes out to 1.25. And so what it was asking is, what is the distance? What is between 37.2 and 42? Because 37.5 is this, and 42.5 is this. So the answer is 0.787. Does that make sense?
Yeah.
Because it's between the two. Have I BS'd enough yet?
Yeah. No, it makes perfect sense now. I'm like, I can't believe I missed this.
Well,
and I watch the tutorials. And I even go and select the certain problem that I have a problem with, and it still just goes over my head. But when you like write the formula out for me, I'm like, oh, that makes sense.
Well, and that's why everybody learns differently, and I don't learn by a book. You need people just a step-by-step process. That's great. I learn a little bit different. Everybody has different methods of learning, and I think, I mean, if I can help out, great. I mean, and this helps me out because I'm practicing it, and I'll help me to remember. Because when I take the test, I don't have a mental dump before the test. I'll have the mental dump after the test. So,
during it? No, I'm kidding.
No, I don't want to during it. Not during.
I know. I will during. Okay.
All right. Well, I think we're done, and we can start the test now. Hopefully, right?
Yes.
Cool.
Let's do it.
All right. Yeah, because hopefully the test doesn't take too long. So, all right. Cool.
I hope not.
All right. I'm going to stop the broadcast, and we're going to go ahead and go on the test.